So we
Thank you,
shall go
Chitra.
on to our last speaker, another amazing surgeon, Dr. Anurag Mishra, who's a consultant pediatric squint and oculoplasty of Kar Vision Eye Hospital. I want to know what he is doing with the cataract still. So another great surgeon who is very techno-savvy, and you can see it in this photograph itself. So we really need to know all that you're going to tell us about advances in IOL technology. On to you.
Thank you so much, ma'am. Good evening, ladies and gentlemen. Gratitude, ARC, Chitra ma'am in particular, not only for the platform, but also for the topic, because it propelled me to take serious deep dives into some very interesting concepts. So hang on if you thought that the IOL technology has reached its summit and perfection, because there's still a lot more coming up. And here's my list of recent advances in IOL technology. We'll start with one concept which has already received the US FDA approval. It's called light adjusted lens. And the light adjusts this lens after it's implanted in the patient's eye. This concept was introduced by Daniel Schwartz and Robert Grubbs, and it got an approval in 2017. The material of this IOL is it's built up of macromers, which are photosensitive molecules, essentially, and it's embedded in a uniformly silicon matrix. So the material is silicon. That's what we are going to start with. The concept with which this IOL works is, these are the macromers which are there, the pink shaded things. After IOL's implantation and you do a refraction and find a refractive surprise, the IOL gets exposed to light, UV light, of a wavelength of 365 nanometers. What it does is, it propels the macromers to join ends and produce polymerized macromers. This creates a concentration gradient inside the substance of the IOL, and the unexposed macromers travel to that area, increasing the curvature and thereby altering the dioptric power of the lens. After that, a second bout of exposure to the same UV light is performed to lock in the effect so that no further change can be produced. So it's a very interesting concept indeed, but there are a few buts. So this is how a myopia is corrected. If you have a residual myopia after implant, the light is projected onto the peripheral parts of the iris, peripheral parts of the lens by a light delivering device or an LDD, which is kept at the OPD. So the IOL assumes essentially a dumbbell shape. It becomes a biconcave shaped IOL. And then there's a lock-in to adjust the myopia that the patient was residuing with. In contrast to that, if a hypermetropia is residual, then the central part of the lens is exposed to produce the same effect. It increases in its curvature and convexity to adjust the dioptric power and give you a proper optimal correction. There are a lot of flip sides to start with. It is a material which is made of silicon. We all know what comes with a silicon material. What all comes with the silicon material. It's a biconvex, it's spherical in its design. The aspheric design has not been come out. It's a three-piece or a multi-piece design. It's not single-piece design. It's something they have not come out with as yet. The pupillary dilatation of the patient has always to be on the other side of 7 millimeters. A smaller pupil, you just cannot do the procedure, because if it's a myopic residual, we just saw that the peripheral parts of the lens have to be exposed to the UV light. After all this juggling, what they found is 92% of the patients with a 0.5 dioptrosphere and 82% within 0.5 cylinders. Well, you ask yourself, without all this juggling, perhaps my patient population also fits into this sphere. So why this? Protection against UV light in nature. UV light exists in nature. So the patient wanders around after the IOL implant. The naturally existing UV light can also alter the IOL into an extent. So till the time that the patient is exposed to this particular UV lamp in the OPD, the patient is given a pair of UV protective glasses, actually, to prevent any damages or prevent any changes occurring to the IOL. And it is an expensive proposition as well. The second concept that we are talking about is bag in the lens. This was introduced to the world by Mary-Jo Stazington. The material is hydrophilic acrylic with 28% water content. Well, you again say that this is perhaps not good enough in the present technology. It's a biconvex disc. It does not have haptics. It's just a disc having a circumferential groove. And the technique is you do an anterior rhexis, you do a posterior rhexis, and then implant this disc and feed the anterior and the posterior capsular margins together into the circumferential groove that is there in the IOL. The capsulotomies have to be matching in size and centration. However, they may not be congruous, in which case only one part of the capsular rhexis margin can be fed. To ensure a match into the circumferential groove, the innovator has also designed a caliper, a ring caliper, which comes in, and you can use that to mark both the anterior and the posterior capsules. High molecular viscoelastic, high molecular weight viscoelastics has to be pushed into the Berger space before you perform the posterior capsular excess. And after you put in the IOL, all that viscoelastic has to be washed from behind the IOL, which might be a little difficult because both the disc and the excess and the capsule and the capsules anterior posterior combined would be flopping in there. If you have, if you have a desire to have a perfect match, then you also combine with flax. But with flax, you have to do the PCCC and the ACCC both with the flax machine. So that consumes 2 of your PIs, just escalating the cost for the patient. And if you have a capsulotomy break or a zonular dehiscence, they've also come out with these segments, which they call the bean segments. They are also to be fed into the circumferential groove on one side, and the other side rests in the sulcus to give them a proper fit. This IOL is also available in the toric versions. And the only practical advantage with this particular design is that it does not lead to any PCO. They have also come out with something very interesting. They say that if you implant a bag in the lens IOL, then there is a minimal myopic shift in pediatric eyes. Why? Because the lens epithelial cells remain in their natural position, and that is how they keep the bag flexible and stretchable. So consequent to the stretch in the eyes with advancing age, it perhaps does not lead the patient into too much of a myopic shift. But there are a lot of flip sides of this. They haven't mentioned anything regarding ELP and how a constant modification should be done in the power calculation part. Technically, it is a difficult procedure and an expensive procedure as well. And finally, future posterior segment surgeries might just be difficult because you have a long opacified area in the periphery, all thanks to the opacification in the capsule, which is bound to happen with time. The third concept is drug eluting IOL, which essentially is a drug delivery system of IOL when it's put into the bag, and the concept actually augments dropless cataract surgery. We have gone into needleless, we have gone into sutureless, we have gone into bladeless. Now it's time that we look at dropless cataract surgery. There are 3 ways in which drugs can be added onto the IOL. Either you coat the surface, in which case the whole surface of the IOL is coated, barring the sides. Soak the IOL in an active molecule, in which case the sites also get impregnated with a solution. And the final drug delivering technique is loading the IOL haptics with slow release devices, which release the drug after they're implanted. These are the drugs tried: dexamethasone, ciprodexa combination, moxodexa combination, and this doxorubicin incorporated chitosan, which essentially prevents the future posterior capsular opacification. So all of them have been tried, but they have been tried in models and animal models as well. The advantage, as we discussed, is just it ensures a dropless cataract surgery, perhaps sometimes in the future, but there are a few flip sides as well. The first of foremost of which is this hydrophilic material again, because otherwise you perhaps cannot make the drug soak into the substance if it's not a hydrophilic material and is not permissive to the solution that you dip it in. It affects the optical quality. They've seen that it initially does affect the optical quality till the drug is delivered fully, and then the optical quality improves. So for that time period, the patient would have to manage with a compromised quality of vision, which perhaps would not be acceptable. Intracameral concentration after the initial delivery is not predictable. So we need the intracameral solution of the drops to be continued for a period of time after surgery. We're not sure that whether that period would be covered with the one load of drugs that are incorporated into the IOL substance. The next slide would begin with some amount of glamour, actually, because this features an outrageously good-looking man who is also the innovator of a swivel haptic IOL, a very interesting concept. Again, I'm thankful to Dr. Sri Ganesh and Dr. Sheetal for allowing me to include this in my talk and also share with me the material. This is an open-loop single-piece hydrophilic design, but it has a set of extra haptics at 3 and 9 o'clock positions, which stay folded when you load them onto the cartridge. But once it opens in the bag, you just have to swivel them, and they suspend the rest of the IOL from the anterior capsule. The advantage is
Sir, you have 1 minute remaining.
Is it has more predictable ELP. It has no decentration or tilt, and it negates the negative photopsia as it stays very close to the posterior surface of the iris. But the flip sides are, well, it is a hydrophilic material again. the contact with posterior capsule is presumably going to be less. Estimated A constant they have told is 117.5, but their article also suggests that they had seen a change in the spherical equivalence from plus 1.75 diopter to minus 0.75 D in a period of 6 months. I would have loved to have Dr. Sri Ganesh's opinion on this. The final concept that we are talking about is EDOF without multifocality. So diffraction-free EDOF, a very interesting concept that has come nowadays. Before understanding how it works, we have to see how the depth of field works for us. So this is the visual field where the near, the intermediate, and the distance objects are placed. With a monofocal lens, we have just one point focus. And when you have a near object being looked at, the focus changes to behind retina, and you have a blur circle coming into focus on the retina. So you cannot see things properly when objects are located in a nearby distance. What the EDOF does is it stretches the point focus into a line focus, and it also shifts it so that when you have the distant object, the rear end of the focus comes into this focus on retina, and you have a near object and the proximal end of the focal line comes into the focus in the retina. And how it does it is by extending the central part of the wavefront into a line. So that's how it does it. And I will just look at this small animation. So this is a normal wavefront, and this is the extended wavefront. How it does is in the IOL is that there is a small modification at the center by means of a smooth plateau and a curvature change right at the center of the IOL, expanding 2.2 millimeters. So it converts the focus into a line, all right, and it also shifts the focal line into a little anteriorly. So it expands the wavefront, and it also expands the focus, and it brings it front. Advantages: there is no light distribution in this technology of 87 and 13 for distance and near. So there's presumably no effect on contrast sensitivity. I just wanted to add a point to Dr. Samaresh's talk in this, apart from doing the other things on eye trace, a part of my routine workup, particularly when I'm planning an AT-IOL, and in particular when I'm planning a multifocal or trifocal, is to see the modulation transfer function curve on eye trace and to look at my patients where they fall. If they do not fall well within the square that the machine gives me, I'm very careful because their contrast sensitivity is already compromised and the multifocal is going to compromise it further. I do agree that angle alpha does not play a major role, but what plays a major role, in my opinion, before you plan this is looking at the modulation transfer function curve. So there are a few flip sides. You cannot have a perfect EDOF according to principles of physics. There is a curvature change, so you might have compromised quality of vision. Before we wrap up, there's just a few honorable mentions. This is my last slide, so hang on just for a few more seconds. There's a concept called open bag IOL. And this comes from a thought that we have seen that if there is a free passage of aqueous into the capsular bag, it leads to less of PCO formation later. So what this open bag IOL does is, it has a 2 layers of complete circles of haptics bridged by pillars, vertical pillars in between, which act as conduits for the fenestrations. They act as conduits, and they allow a free passage of aqueous into the bag. Fluid-filled IOLs and modular IOLs are essentially accommodative IOLs. They have haptics which are silicon gel filled, and they're accommodative. So the flow of silicon oil gives some amount of pseudophakic accommodation. A variant of light adjusted lens, the LAL, is femtolaser induced alteration in IOL power. We call that FEMTIS, or the innovators call that FEMTIS. It is better than UV light exposure, at least because you don't have femtolaser light in that wavelength occurring in natural light. So you don't have to be very protective to the patients. You can always do that later on, exposing to the effects of femtolaser, bringing about the same change. Sorry for overshooting the time, ladies and gentlemen. Thank you so much, Dr. Chitra, again, for the opportunity and the topic. I sign off now.
Yeah, wonderful talk, Anurag. You really opened up the whole world of recent technologies. I have a question to you. When you are choosing a new multifocal based on the different benchmark studies, would you want to look at the defocus curve, the modulation transfer function, or the point spread? Which of the 3 would you prioritize on?
All 3 of them, ma'am. It's very difficult to prioritize, actually, because all 3 of them play a very important role. The defocus curve definitely is important because we have to know the patient's lifestyle and the concentration and the cord length of the lane length of the patient. So that has to be identified with precision. And the modulation transform function curve, as I said, it always forms the routine part of my cataract evaluation, particularly when I'm planning an AT-IOL. So point spread function again is important, but point spread function is perhaps not that important if you are taking into the lower order aberration correction precisely. If you're correcting the lower order aberration very perfectly, then the point spread function is going to have a confluence of very acutely compact spots. So that perhaps will take the third spot, but these two are equally important to me.
So I have a question which even Anaga or Satyajit could also answer, or you could answer. What would be the percentage of this enhanced monofocal in your practice? Would you use it just as an alternative for a 3-piece IOL and with some depth of focus, or you believe some more in it?
At the moment, there are only two concepts lying with us. The one is called the IHANS and the other is VVT. Now, there is a massive difference in the price factor of these two IOLs. While I've used both, I must say this, that the IHANS is, to me, it's just a monofocal IOL. It does give a little bit extra in a few cases after bilateral implantation, and in particular, if you are leaving the patient behind with a small amount of myopia for distance. The VVT performs better. It is better in its performance, but it is very highly priced. So at the moment, VVT occupies that small segment of patient population in my practice, wherein the patient's interested to have an added intermediate vision in particular and a workable near vision, but is unsuitable for trifocals otherwise. The patient's a frequent night driver, or even otherwise the patient's unsuitable for trifocals. That small segment of patients is where I choose the VVT for.
Thank you. Anganaga, you have anything to add? I think he said it all, no? Anaga, signal's not there.
Ma'am, there have been issues of glare and halos with IHANS. What is Dr. Anurag's take on that?
As I said, Dr. Satyajit, I mean, even without halos, it does not somehow, apologies for saying this on a platform like this, but it does not really make me happy post-implantation feedback from the patient. So not a very avid user of that. Sorry.
Okay. So I think
Same here.
Get back to our dinner, and I think I shall make my concluding remarks. Satyajit, you want to say anything?
No, ma'am. No, ma'am. I'm done.
So I think we today definitely stand stronger with a very refreshed understanding of all the relevant technologies which we need to embrace in cataract surgery. And on behalf of ARC, a very heartfelt thanks to our dynamic set of speakers who truly added great value to the webinar with their thought processes. And of course, our great expert panel who ensured that all the pearls were brought out at the relevant moment. My deep felt thanks to all my wonderful co-moderators, Anagha, Satyajit, and Srinivas Joshi. And of course, the great team that we are together. My thanks are due to the AIOS admin led by Mr. Kripal, Sai, Manjula from Numerotech for the solidarity of support, and the highly charged office staff of mine, Mr. Vel Murugan. My thanks to the webinar admin led by Anand Sethi, who really look into all that has to be seen. And my gratitude and solidarity to Entone. I'm sorry, solidarity to Sun Pharma. I'm so sorry. This is a PG update, and the PG update is so close to heart of Sun Pharma for sponsoring our PG update events in the recent past. And finally, immense thanks to attendees for their gratifying presence and that encouragement which they give us to try to come back to each of you with newer and newer programs. Stay tuned with us. Stay tuned with ARC. Thank you very much, one and all of you. Thank you.